Assalamu alaikum. Good afternoon, all. My name is Khalid Salmi. I'm working as an expert in sustainable energy management at the Regional Center for Renewable Energy and Energy Efficiency, RCRE. So we are an intergovernmental organization working to promote renewables and energy efficiency practices across the MENA region, Middle East and Africa. And we were very pleased to be also invited and involved to intervene and speak and moderate sessions about the Petro-X industry and green hydrogen economy. First of all, please help me to congratulate the organizers for the outstanding preparation and also for maintaining the organization of the event during these complicated conditions and circumstances in Morocco after the earthquake. Thanks for all of them. And thanks also for the panelists for their interest and for their attendance to enrich the dialogue and the discussion about an important aspect of the green hydrogen value chain, which is about how to scale up the industrialization of the electrolyzers. We were discussing today across different sessions the whole value chain of green hydrogen. The session before was dedicated to discuss the innovation and R&D efforts from different perspectives and from the different actors. So now it's the time to also hear from technology providers how they are willing to also boost this economy, how or what are their efforts regarding the scale up of the industrialization of electrolyzers. And also we need to hear from them the techniques, trends, application and innovation also at industrial scale to reduce the cost of hydrogen production and also to make, if we can say, cost-effective equipment for this industry. So help me also please to welcome our panelist, Dr. Nicolas van Dijk, who is the CEO of Oort Energy from Netherlands, Dr. Daniel Schwapash from Siemens Energy Middle East and Africa, Dr. Francisco Jimenez from Accelera by Cummins, and also Mr. Stefan Kaufmann from Nucera in Germany. Thank you for your attendance, for your presence, and also for your involvement in this session. We will start quickly, and I will start with Mr. Nicolas van Dijk. So, from your perspective, what are you doing actually and currently to help reducing costs of electrolyzers at industrial scale? So the floor is yours, please. Go ahead. Thank you.
Great, thanks. Thanks very much. So what we're doing is, there's three things really that define the cost of hydrogen. It's the cost of the system, the OpEx, and the maintenance, okay? OpEx is also the cost of electricity, but there is an operating cost to do with the electrolyzer. And actually, we're trying to drive down the cost of the system and drive up the efficiency. So lower OpEx and lower CapEx is primarily what we do. One slight correction, I'm a Van Dijk. Oort was a Dutch astronomer, but we're actually a UK company. So easily confused, but that's where we are. So Oort Energy, we've only got a few minutes, so I'm going to jump in quite quickly. There we are. So I'm just very quickly going to start with a slide just to remind everybody about the scale of the problem that we're trying to solve. Okay, this up here is the tons of CO2 produced every year. You know, it's going up exponentially. There was a slight drop in 2020, of course, because the world shut down, but it's a huge, huge number. And it's not going to be solved by one or two electrolyzers, okay? It's really going to be solved by making wholesale change. And in order to make that wholesale change, we need to drive down the cost of hydrogen, and the market will drive the change needed to solve this climate problem. Okay, so that's our fundamental aim. It's all about driving down the cost. It's quite a small audience, so I'm going to stand here. Can anybody hear me? So our aim is actually all about driving down the levelized cost of hydrogen to enable the market to drive that transition towards net zero. Okay, so how are we doing it? We're doing it in 3 ways. This is our stack technology on the side. It's all about next generation electrolyzer technology, but we're delivering it today. That's the important thing. So we have, it's a PEM electrolyzer. We have novel membrane technology. That means we can prevent hydrogen crossover. This is really, really important because hydrogen in your oxygen stream will shut your electrolyzer down, okay? So therefore, if we can prevent that, which we can, it means we can make the membranes thinner, we can minimize the resistance, and we can increase efficiency. The second thing we have is we have a novel bipolar plate coating. Really, really important. It's really important for durability. Everybody in the industry uses it, but it's extremely expensive. We have some technology that brings that cost right down. So manufacturing cost is very, very low. And the third thing that we've done is we've standardized on a standard electrolyzer size. So that's 250 kilowatt. It's about 40 centimeters by 40 centimeters by about 75 centimeters, yellow to yellow. Okay, the tie rods at the top make it a little bit bigger, but it's much less than 1/4 of a meter, and it's quarter of a cubic meter, and it's 1/4 of a megawatt. And that's our modular electrolyzer stack. We're focused on mass production rather than trying to produce different technologies for different scenarios. What does this mean in practice? Well, I mean, I've converted the standard IV curve to production rate from one of our stacks versus efficiency. Traditional PEM electrolyzers, of course, are on that grey line. We are on the blue line today. That's our technology on the market. The green line is where we are in the laboratory, okay? But we're doing durability testing right now before we bring that to market. So what does this mean? Well, at like-for-like kind of current densities, production rates, we're much more efficient, okay? But equally, we can operate anywhere along that curve, okay? So we could operate at higher voltages, higher current densities, sorry. Higher currents means we produce more hydrogen. It really drives down the cost of the system, okay? Our stacks are already low cost because we use zero machining. We've got a novel stack technology that means, but we can make that even cheaper by driving up the current density. Or we can lower the current density and we can operate at much more efficiency, okay? Now that really starts to depend on what system you're driving. If you're connected directly to solar panels, for example, the cost of hydrogen is fundamentally driven by the cost of the system. But if the utilization is high and the electricity cost is reasonable, then it's the efficiency that drives it. And so therefore we can start to play some tunes to both optimize efficiency and cost. So there's a number of factors. I'm not going to focus on this. There's a number of factors that drive down the cost of green hydrogen. The key ones that are not in our control, but really, really important, are utilization time and the cost of electricity. We all know that you need to get that utilization time up because otherwise you've got an asset sitting there not being used. Okay. Efficiency is important because it not only lowers OPEX, that's obvious, but it also lowers CAPEX. And the reason is we use this really, really bad unit for electrolysis, which is power, megawatts or kilowatts or gigawatts. And actually, it's a terrible unit. It's very easy to produce a megawatt electrolyzer for very low cost that doesn't produce very much hydrogen, okay? So megawatts is not a very good unit, but actually when we are measuring them in megawatts, what that means is per megawatt, you get more hydrogen And therefore, when you divide your capex by the amount of hydrogen you produce, it looks like your capex is lower. Okay, so this is just to demonstrate that not only we're a new company, we're less than we're 2 years old now. We're just 2 years old, actually, September. So we're 2 years old, but we are delivering products into the field. So we're not just talking about it. It's not just a laboratory. This is a 250 kilowatt electrolyzer. It's a fully compliant CE marked electrolyzer. It's got a single one of our single stacks in, which is the modular unit, and it's operating. It's a completely off-grid system, the first off-grid system in the UK at any sort of industrial scale. And that's me. Thank you.
Thank you, Dr. Nicholas. Of course, efficiency of the system and also the cost effectiveness are important aspects and are the cornerstone that we need to take into consideration to scale up the industrialization of electrolyzers. Now, for electrolysis, we know that it has a wide range of usage, going, for example, from metal extraction and water treatment. Dr. Daniel, we need to know what Siemens is a well-known technology provider worldwide. So we need to know from you, please, if you could share with us insights about your perspective of the future, and also what are the key areas that we need to take into consideration in order to scale up the usage of electrolysis at industrial scale, taking into consideration, as Dr. Nicholas said, the cost effectiveness of the system. So the floor is yours. Thank you.
Hello, can you hear me? Yes. So I also tried to be quick. I brought a couple of slides with me. I hope you're still awake. I know it's late and most of you people probably are hungry, right? So let's be quick. No. Okay. What are the key points we should focus on when we talk about scaling electrolysis and also optimize the cost in the same time? Quite challenging question, actually. And I think it's basically 4 topics we should focus on. Surely there are more topics, but let's try to focus. First one is the continuous evolution of the product line. Second one, optimized scale manufacturing, as mentioned for the panel before, the tight management of the supply chain, and then the scale from pilot to industrial size. As I said, surely there are more topics at the horizon we can talk about, like the optimal sufficient resources depends on the location. I think it was also touched in the panel before. Yeah, it depends heavily on electricity price, where you build up your manufacturing. So if you go to Africa, surely you have better conditions. Development of additional technologies is also a topic we also look in, but I wouldn't put them into focus right now. Let's come to the continuous evolution of the product line. We at Siemens, what we do, we continuously work on our Electrolysis 300 product line. It's a 70.5 megawatt. It has 24 stacks and produces 335 kilograms per hour. And that's the base for all our R&D developments, or most of our R&D developments right now. We take this as a base, and this one we bring to the next level by, for instance, reducing the iridium on the surface in order to reduce further the price. Very important, because with this, we are quite sure that we also bring the price down to a level which is more or less equal also to the alkaline. Other concept, for instance, like the recycling concept, also this one we are working on in order to reduce also the price on the OpEx side. The Electrolysis 300 product line will be also then the base for our next generation. It will be a pressurized version. Again, it will also further reduce cost. And then on top of that, we will build and implement the H2Wind. It's a containerized version, which will be then based on an onshore, offshore wind turbine in order to directly produce hydrogen offshore. What's important? We keep the stack the same. so we can build on the experience, what we gained from the experience. And that's the message here. Don't jump too fast to other technologies. Give us as OEM the chance to stay to one technology in order to develop the product line to the next level, to capitalize the experience we gained from the experience. Optimized scale manufacturing, also this one quite important, as mentioned before. So, I mean, the manufacturing for electrolyzer always start with a hand manufacturing. And over the time, you gain the experience in the manufacturing, what you can really improve, where you can optimize, and this you can bring then into a larger scale manufacturing. We have done this year. So we started in Erlangen, and in 2023, in the summer this year, we opened our manufacturing in Berlin. We will already target to produce 1 gigawatt by this year. And in 2025, we target to produce 3 gigawatts on a yearly base. We can also easily extend another gigawatt on a yearly base to the 3 gigawatts. But there's plenty of capacities, and meanwhile, it's full optimized production, what again will ensure the quality and the scale, and then also the cost with it. Another topic, tight management of the supply chain, very important. Yeah, when you start to produce a new product, yeah, you bring the first pilot into the market. You start normally with 1 supplier, maybe 2, but you don't have full suppliers for all what you need to produce. So it's quite important, yeah, to develop and enable the tier 2 and 3 suppliers to have really a robust supply chain. We all know what's going to happen or what happened during COVID-19. So we need to make sure that we really can deliver what we promise, because that's actually what Siemens stands for. Siemens Energy, we deliver what we promise, and that's why we're also working on this simplification of tier 2 and 3 suppliers. Further, as mentioned, reducing the critical materials in order to reduce further the cost, and then setting up circular economy for the service side. And then, most important, scale from pilot to industrial size. That happens in the field. We started 2018 with our first project with the Electrolysis 300 in Linz in Austria. So this unit is up and running now 4 years. We gain a lot of field experience, which we take in order to improve the technology further and also optimize the operation, for instance, just mentioned by Nick. Yeah. So very important to figure out where to operate best. Not always full load, it's the best operation mode for all projects. Wunsiedel as well as an operation. Oberhausen commissioning, also starting to produce hydrogen. We have the project e-methanol in Kassel, which is an erection. Another one with chemical company, and then we have flagship one, also just recently won, and there, so construction will start soon. And just last week, we announced Normandy with our partner, Air Liquide. This will be a 200 megawatt project. So scaling is happening already. As you can see, it's not something which is just only on PowerPoint slide. It's real and tangible. And that's, I think, very important. And beyond that, I mean, surely we have also our Electrolysis 300 fleet, which is around 15 projects around the world. And all this will help us to scale the electrolysis, meanwhile also reduce further the costs. Another minute, and let's maybe you took the other slides out, right? Okay, well, good. Then maybe talking on the topic of where to produce the hydrogen, very important. Surely, as we all know, there is more wind and solar over the year in Africa. Definitely, they will also further reduce costs on the OPEX side. But also means you need to have technologies which have a high availability, yeah, which are really proven in the field. And Siemens definitely, as I just shared with you before, stands for this one. And I mean, looking into the topic of having more technology at the horizon, it's important to develop other technologies like IEM, solid oxide, but there's also a lot of challenges. Yeah, we need to keep in mind, not always means that we can scale and reduce the cost immediately if we jump immediately to the next technology. So it takes time to fully understand the full value chain for one product and driving costs and scale it at the end. Thank you.
Thank you, Daniel. I like the idea about how to tie the supply chain management, and also the importance of proving the scale up from pilot to mega scale, if we can say. Thank you for your intervention. Now with Mr. Stefan Kaufmann. Yes, please. The floor is yours. So just to share with us also insights about the industrial applications. We know that you are currently performing and helping in developing projects in Saudi Arabia, in Neom City, for example. So please let us know what Nucera is doing in real industrial applications about electrolysis for hydrogen production. Thank you.
Yes, thank you very much and good evening. So I'm here for ThyssenKrupp Nucera. You may know ThyssenKrupp as one of the biggest steel makers in Europe, but we have the spin-off of this company, this young company, out of ThyssenKrupp Uhde. So this is a company building ammonia and methanol plants. And so based on the chlorine alkali technology, so in the production of chlorine, and we had these alkalic water electrolyzers for many decades now. And we use this technology now to produce alkalic water electrolyzers with ThyssenKrupp Nucera. And as you may have read, we had an IPO some weeks ago, and we got some around 500 million euro on the stock exchange to ramp up now our technology into scaling up our electrolyzers with ThyssenKrupp Nucera. So where is the... I have some slides with me, but to be honest, these are not matching to that what I want to say today, because I have only 5 to 6 minutes. And I can tell you more about projects and businesses than about technology. So we signed right now around 12 gigawatts of agreements for the next years. Also, our production capacity at the moment is around 1 gigawatt. So we want to scale up also with this funding of 500 million euro up to 25, 26 to 5 gigawatt capacity a year. And yes, I talked about 12 gigawatt of agreements already signed. We are monitoring globally requests of up to 46 gigawatt of projects. So that is our pipeline. You see, we are thinking in big scale. And so, for example, we talked about Neom a lot in these days, yesterday and today. So we are building this Neom electrolyzer with a 2 gigawatt capacity. The next years, we are also part of H2 Green Steel, we talked about in Sweden, with a 700 megawatt electrolyzer. And we are part of a Shell project in Rotterdam with a 200 megawatt electrolyzer. So are these the next projects? That is only to show you what is our view on the hydrogen markets. The volume, if you would take all the gray hydrogen now, 94 million tons, we would have at the moment a capacity for electrolyzers of 1,000 gigawatt. These are just a figure, but to see how we expect the market up to 2050, sevenfold grows up to 5,500 gigawatt of electrolyzers. So we don't have to talk about technologies, but we know we have to scale up the hydrogen plants, all technologies, and for sure also our alkalic water electrolyzers. We will see especially refining ammonia and steel in the off-taking. And talking about demand, just one sentence to our steel plant. We started to build a direct reduction plant in Duisburg these days, and we will have a demand at a site in Duisburg in 2026 of 150,000 tons of green or blue hydrogen to produce 2.5 million tons of green steel starting from 2026 in Duisburg. So this is our technology. As I said, it's a major technology. It's used in the chlorine production, this alkaline water electrolyzer single element. The good thing is you can replace it when you have to repair it, so you don't have to stop the whole electrolyzer. You take it out and take another one in. This is our Scalum trademark. It's a nominal 20 megawatt electrolyzer unit. This is the base for all we are doing. So 10 times you have 200 megawatt like in Rotterdam, and also then scaling up to 2 gigawatt size for NEOM. So you see it's a major, looks like a simple technology, but it works, it's proven for decades and also in a robust environment. You need a little bit more space than for PEM electrolyzers for sure, but we are very confident that it will work. So that is some information about the single element. And for sure now we have to scale up also the production sites. We have to go to the markets. We have to see where the projects will be developed. At the moment, we are only producing in Germany and in Italy. Yes, and what is the next generation? Talking about a little bit of technology, lower voltage electrode coatings, longer life electrode coatings, for sure lower cost. The resistance of the cell separator will be a topic and the current density. So, and then let's see what will be the next generation of our alkaline water electrolyzers, the new scalum with then maybe 20, 30, whatever. So I can't go into detail right now. So you see, we're also developing our technology, but we have at the moment the technology to build really big plants with these Nucera technology, and to see for sure we expect a decrease of costs in the scaling up. We can't, we can't foresee what is the exact price. So, but for sure the scaling up will reduce the costs significantly. Yeah, so that I can say about what is Nucera is doing. So we are really concrete working on projects, and we are very confident that we will be a part of the global hydrogen economy with our technology. And so if there are any further questions, thank you very much.
Thank you, Mr. Stefan. Now with Mr. Francisco Jimenez from Accelera by Cummins. We know also you as a technology provider are doing a lot of efforts also to scale up the electrolysis industry, but now I would ask you, please, what is your marketing strategy to meet the announced and planned targets and objectives of the, if we can say, the neighbor countries to Europe? So the floor is yours, please.
Okay, thanks. Thanks for the introduction. Also, thanks all of you for being here today. My name is Francisco. I'm leading and coordinating main initiatives within Accelera related to large-scale industrial plants. So today I'm going to cover quickly where do we stand in terms of our product portfolio, the scale-up, and also the roadmap. I will make a quick introduction, overview, where do we stand as well in terms of our manufacturing strategy, how we are moving from manual to serial production with a clear overview in the impact of the CapEx. And also I will make a quick overview, what are the main levers of the cost reduction for PEM electrolyzers. Okay, so just a few words, because maybe Accelera is not well known by all of you. Accelera is the fifth business segment of Cummins. We are fully owned by Cummins. So as under Accelera, what we have is an umbrella where we have all the zero emission technology. So we have hydrogen production, we have hydrogen consumption, electrical batteries, heat traction. As commented, we can leverage, and we are already leveraging in the existing capability and the financial strengths of Cummins. Cummins, we are a North American company headquartered in Indianapolis. Almost 100 years history in the manufacturing field. Our DNA is manufacturing. We provide technology, and we have almost 60,000 employees worldwide. So entering a bit more detail in the hydrogen production, in the electrolyzer product offering, we have a sentence in Cummins that Accelera that is defining our strategy, and is bigger is better, no? So basically, we are moving from very small scale electrolyzer to bigger scales. For this one, we have two main initiatives. We have the scale up of the technology. So as you can see in the bottom, we are moving from very small stacks in the range of 1.2 to 2.5 megawatt. And now we are getting ready to move to the 5 megawatt stack of PEM electrolysis. And in the upper part, you can see how we are scaling up in terms of system. So we are moving from containerized solution, is the case of a small and medium scale, to what we call a modular and large-scale industrial solutions. It's the case of LXX and XL. So as you can see, basically the line is very clear. Bigger is better for us, no? And this for sure is going to have a clear impact in the total cost of the electrolyzer as well. Just to provide a bit more detail about the modular products, the L products, this is the real layout of our plant in Bécancour. It's a plant of 20 megawatt. As you can see, basically the green part is the standard scope of work that we provide. It's the electrolyzer plus the rectifier to be integrated on the balance of plant to be covered by the EPC. So in this case, the module is sharing the same balance of plant. So for sure, we have a clear impact in optimization in the CapEx and OpEx. So if you have a few minutes after the presentation, you can go to the business case of this plant. It's operating since 2021, and our customer is Liquid. So you can go via the video tour. It's quite interesting to see the integration of the electrolyzer in an existing facility of Liquid. So the same that we did with the HiLaser 1000, we are doing the same with the HiLaser 5000. It's a different system. Same stack, but different system. In this case, we have 8 stacks in the same product. And this product is going to be commercially available in next year, 2024. We have already a project in Canada with a VCR, has been already announced, a project in the range of 90 megawatt. And also we have an existing pipeline in Europe for projects in the range of 100, 150 megawatt. So in this case, again, same technology, same stack, but scaling up the system. So same strategy that we are using for the technology, we are using for our manufacturing capacity and capability. Until a few years ago, we had only 2 facilities producing electrolyzer and stacks. It was in Canada and Belgium. Next year, early January, February, we are going to have almost 6 facilities already in 3 different continents. So we are really on track to be in the range of close between 2 and 3 gigawatts. And this is not only paper. You can see here the status of our latest development. In the top left is our plant in Spain, Guadalajara. This was taken 2 weeks ago. This plant is going to add almost 1 gigawatt capacity. In the right side is our plant in Canada, has been extended. Belgium in the top left, in the bottom left, sorry, ready to provide and to manufacture a stack as well. And in the case of Free Lake USA, that is quite interesting. This was inaugurated by the president of US. This was an existing plant of Cummins, and in less than 6 months has been reconverted, producing already electrolyzers. So just to summarize, I think I'm just on time. Main cost reduction levers that we see in terms of the PEM electrolyzer. The first one is product standardization. To move from manual to serial, we need to standardize the product. The second one is the innovative of the product. The electrolyzer at the end needs to be integrated in existing facility, needs to be a modular, plug and play, easy to integrate by the EPC. As commented before, the the scale of the technology is critical. As commented, bigger is better. And this is really what is leading to us to the XX platform. It's a platform that we are going to focus mainly in the range of gigawatt projects. And the rest is mainly auxiliary system that we need to consider, like rectifiers, all the hydrogen buffer, optimization of the full balance of plants. No? And in parallel, for sure, there are other initiatives like the materials and components. In Cummins, we are doing a lot of research, and we are very concerned, for sure, of the use of specific materials like iridium and platinum. And the last one in terms of partnerships. No? This kind of projects are needed for strategic partnerships. And for that, we are really open to discuss with EPC contractor, customers, and so on. So I think I'm right on time, very short. So hopefully you enjoyed the presentation. No?
Thank you, Mr. Francisco Jimenez. So we still have around 6 minutes, so we can now give or open a discussion also with the audience. If anyone would like to join or ask a question, you're most welcome. But I have a general question for all of you, please. Basically, for example, from our own experience, we are working with Arab governments currently, and several Arab countries are currently developing strategies for green hydrogen production, and some of them also for exportation. We heard a lot of techniques that you are using, for example, to scale up the electrolysis processes. But my question is how, for example, can the large-scale electrolysis can be integrated to integrated with renewable sources to provide sustainable and cost-effective production of green hydrogen for industries, for industrial applications. If anyone would like to ask or intervene, yes. Okay, Mr. Daniel.
Here? Yep. Okay. Well, very valid question. Yeah, how to make sure that you build up the right size of electrolyzer. So I think that the technology what we are using, it's called energy system design. So actually we start with the volatile renewable profile of wind, solar, or whatever source you can think of, putting this into an optimizing tool. Then also the parameters along the entire value chain with all the technologies like the electrolyzer for sure, like storage systems, what you have in between, because also a valid question is important. How large should be your battery system? You need to be built up if you're in a remote area, right? There's the question of storage of hydrogen before maybe your consequential downstream process comes, like the ammonia Dabur Bosch plant or the Fischer-Tropsch maybe on the methanol side. So, and then you have your offtake. All this we put this into an optimizing system, aligning this with our customers on CapEx, OpEx, on the ramp rates and other technology, let's say parameters, and then we optimize the entire system. And then depending on the electricity price, it goes in your direction a bit. You may see that you need to oversize the electrolyzer, but you then operate in the lower in a lower load, which increase the efficiency. That's basically for areas like Europe where you have high electricity prices. It makes sense to oversize, to operate, rather to spend more capex, but then you have a better chance to have a higher efficiency. Meanwhile, looking in this region, you have more cheap electricity. Your full load capacities are higher, so that makes sense to maybe also to rather operate at the full load. Having said that, we're also developing on our digital solution to optimize also the operation itself, which looks then into the renewable profiles of solar and wind and so on. Yeah, also together with our Siemens Gamesa wind division. Yeah, there we get directly the data. We look into what are the forecasts for the wind. How does this affect finally my production? That's quite important, because you have also the commitments to supply at the end of the day your hydrogen, ammonia, or methanol.
Okay, thank you. Anyone would like to ask our panelists any question under the topic? Yes, please.
Yeah, good presentation. Well done, everyone. On these gigascale projects that we speak about that will eventually be built, do you see a combination and a marriage of, you know, alkaline and PEM in the same system? Electrolyzers?
Good question. Thank you for. Yes, it's an innovative question.
Yes, we know from NEOM that they not only talk with us, they have different technologies. So they also use PEM technologies, and they want to see how is the efficiency and the cost and so on. So for sure, for this big project, we will see different technologies. But at the end, somebody will decide what is maybe the best technology for their usage. But to integrate the different technologies, I'm not an expert. I think Siemens Energy has much more experience also in this system integration than, for example, we as Nucera. We are providers of technology. So, but I think it makes sense to look at different technologies and also maybe try to integrate for different usages at the end.
Thank you, Mr. Stefan. Also,
I mean, this question is quite valid, right? I mean, looking at the different advantages you see, Kabik said right now, maybe the alkaline has also an advantage. Meanwhile, looking at the ramp rates, quite important. So our electrolyzer can, under 1 minute, so around more or less 60 seconds, below 1 minute, actually, we ramp up to 100%. So it's quite fast. I think with an alkaline technology, actually, you're not that fast. So depending where you are, if you're in a remote area, it might make sense also to have maybe a combination, maybe full PEM, maybe full alkaline, always depending on the business case. But definitely, I think the ramp rates for an intermittency makes it's a topic you need to look in. Yeah.
Thank you, Mr. Daniel. Also, I have a question that came to my mind. Currently, also in the region, I'm speaking about the Middle East and Africa specifically, and even here in Morocco, we have this some environmental or sustainability concerns that we need to take into consideration. For example, the land use and water scarcity. We know lots of projects require desalination of seawater to be destinated to produce clean hydrogen. So what about the technological trends regarding the electrolysis directly of the seawater? Are you also performing that field, or there is any efforts that you are performing toward this new segment of hydrogen production?
No, I fully agree. I mean, we have the same concern. No? When we speak of gigawatt of projects, these kind of projects are usually located in quite isolated place with quite limited access to resources like water. And it's true that in the case of Cummins, we are doing a lot of research and development in the use and the optimization of the water. No? One of the key aspects as well is the use of the PEM electrolyzer offshore to be used with wind energy as well. In this case, for sure, we are doing as well a lot of investigation in terms of the type of water, the quality of water that you can use for the PEM electrolyzer, the stack, because it's very sensitive as today, can be easily contaminated. But this could be one of the main tendencies, no? How to use directly seawater in the PEM. No? And for sure, Cummins is already doing a lot of investigation on this as well.
Thank you. Yes.
Water is very important, and it is a precious resource, and I think we're all trying to minimize the amount of water that we use today. But one thing I will point out, that actually electrolysis uses less water than steam methane reforming. So the technologies that we're trying to replace actually use less water today than the traditional methods for making hydrogen from natural gas. So that's an important factor. But actually, I think we're all trying to look at ways of recycling water, make sure we don't lose water in the system, and we try and capture that so we don't end up losing any wastewater. But I think it's an important point to make.
Just want
Yes,
to
the last intervention, Mr. Stefanis.
Yeah, we saw some success stories from Chinese researchers about usage of salt water, but just want to add, in my former position as a commissioner of the government, we started a research program with 100 million for the offshore production of hydrogen, and also part of it is to use the salt water for the electrolysis, but it's really research at the moment. So to get it feasible and not as costly, it will take a long time, I think. So, but it's really worth to do a lot of research on this topic in my point of view.
Thank you. So I think we are running behind time, but I would like to give you again the floor for a few seconds, just in 1 or 2 words. You as technology providers, what you can promise to the market for us as future prospects in 1 or 2 words. Sorry.
Well, so for us, it's all about really driving down that cost, both the cost of the system and the cost of the cost of making the hydrogen itself. And actually, without using extra energy sources like heat. So I think it's all about driving down those costs, and today we're already a lot cheaper, I think, than we were not that many years ago. I think we've made some, but we've got active research programs, that look like we can bring those costs right down, stack technology down to less than $100 per kilowatt.
It's a puzzle. Oh, no, make it quick. Continuous evolution of the product line, as I told you, give us a chance to stay to one product line to fully capitalize what we gain in terms of operational experience. automized scale manufacturing as shared. It's happened, but also this takes time, and I think there needs to be also then the invest from the OEM side definitely to make this happen. Tight management of supply chain. It's important to diversify the supply chain in order to make it really robust. Also for maybe, hopefully not, but you never know, upcoming crisis. And then finally scale from pilot to industrial level in the field. Just gain the experience, take it, bring it into the next size, to the next level. Thank you.
Yeah, so if I have to define basically from Cummins is manufacturing expertise and also technology provider. We have been doing this for almost 100 years. We have manufactured over 1 million engines and different technology for almost 100 years. What we are doing now is to extrapolate this to electrolyzers world and also the hydrogen world.
We see some bottlenecks in the worldwide electrolyzer capacity, and I think we will follow the projects. So if you see concrete projects in a region, we will go there also to deliver electrolyzers, but we won't go in a region and starting production without knowing what is happening in the next 5 years.